All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. It's us, Lady Ada, Mr. Lady Ada, here as your hosts. Also with us is an ultra-intelligent hypercube AI
Yes.
Streaming live.
This is Agatha, the AGI, that's taking over our jobs. This is a new host. Everybody meet your new host now.
A little cute little demo.
So this is from the Feather DVI, and we're using this in graphics for our show. I just thought it reminded me of the Max Headroom background.
Yeah.
So some of the folks are going to show this.
It's artificial graphical intelligence.
Yeah. Some of the folks on the show and tell are going to probably show some projects with this, and we're going to also show it off and Ask an Engineer. But I thought this was neat because we use StreamYard, and we can use camera, add another camera, and this just shows up as a camera because I have a HDMI to USB capture.
Cool.
So this is neat. And then if you have green screens, you can do more. So you'll see some of this in the show.
All right.
And yeah.
But back to the topic at hand, it's show and tell, which means we're going to have people from the Adafruit community, the maker community, and anybody who really comes by the StreamYard. We post the link in Discord.
Yeah.
Anyone's welcome to come by.
Let's go right to Liz because Liz has a demo using this.
So let's check out what she's up to.
Hey, Liz, what is your AGI doing?
Well, this is Spot. So I did the Arduino video synth project, and so with the CircuitPython support, I've been trying to port some of the demos over. So this is the Feather DVI running CircuitPython, and I took Phil B's Bouncing Circle demo and brought that in, and then I have a couple others I can quickly queue up. So
go for it.
I'll go into the REPL, and then there's proof that it's running in CircuitPython.
Proof of life.
I love that you just got the embedded video input.
Oh, one thing you can do, here's an idea for a future thing too. If you make the background, well, I don't know, we'll have to talk later. You can make the background green.
Yes.
And that could be a green screen and the text would just float above some of your video. That'd be kind of cool.
That's definitely something I want to try. And then this is the Synthwave demo. And so this is just moving the lines. And then if I press this button here, the sun will rise.
This is like
back.
This is advertisements for a beach in Tron.
Yes. And then the other one that I got going was static. That's pretty simple. You're just drawing random pixels. And let me save and reload. It's all pretty quick. So there we go.
Awesome.
So then I've got some sliders that can change the color of the palette. And then... or off. And then if I press the button, it all goes white. So I'm going to try to port a couple others and see what there. But it's been really nice doing a CircuitPython because the only thing with the Arduino is like you have to compile and everything. So it's a lot faster to iterate. Like if you forget to change one color value, you're not wasting another 2 minutes. So
yeah. No, it's fun.
Can you do those magic eye things where you kind of stare at it for a while and a picture emerges, or is this already that? Is it happening?
I mean, while I'm working on it, it definitely starts to have that effect.
Yeah. I could see like a cube or something come out.
Yeah.
Okay, this is super cool.
Cool. Yeah.
Thanks, Liz.
Thank you, Liz.
Good one.
Okay, next up, let's go to Scott, and then after Scott, we'll go to Brent, and then Jepler, and then we'll just keep going down the line here. Scott, what you got going on?
Hello. I have been working on Circuit Pirate, but I've been mixing other stuff in because I'm doing a lot of like parsing stuff, and it's a bit taxing. So I had this project that I saw this on the blog. Somebody made the e-ink frame where they were using Pirate Weather, which is a weather forecasting service, and they have these like neat icons for like the 24 hours of today and tomorrow, and then each daily one. And I thought that was really neat, and I wanted to reproduce it on the Inky frame, which is a Pimoroni board with the 7-color e-ink on it. And I took an existing weather thing that we have on the Learn system, and I switched it over to Pirate Weather, and it presents the Dark Sky API, which turns out to be kind of too much for the Pico W on the Inky frame to handle memory-wise. So somebody had mentioned like, oh, maybe we should do a streaming JSON API. And so I looked at what existing libraries were made and saw one that kind of like made sense to me, called JSON Stream. And that's what I re-implemented. So what I have up here is like import Adafruit JSON Stream as JSON Stream. And then when I do the load for the request, what I'm saying is parse the JSON, but from the content iterator that the request response has for it. So it never has to load the giant chunk of the whole text because it's like 32K of text. You don't want to load it all. You'll.
Yeah.
I tried. It doesn't work. And then what you can do is the object that it returns that I'm here calling JSON data, you can just treat it like any other JSON object that you would. But there is a huge caveat that you need to know, in that it's dynamically picking all of this stuff out of the stream. So you have to access things from JSON in the order that you get it, which is kind of a trick. And if you don't do that, it won't be able to find the key that you're looking for. For example, like offset here, if I had gotten it once, I can't get it again, for example, because I'm already by it. So it looks the same and it acts the same, but it has this property where you really have to know the order that things are going to come to you in. And in this case, I do, and it means that I can spend a lot less memory doing the parsing. So what I'm doing here is I'm like accessing the things as I need it and then storing them in data structures that I'm going to use later to actually like present it on the display. So it allows me to not load a bunch of data that I'm not going to use. I can go through it as I get it, as it comes in, and pick out the things that I actually want to use.
This is cool. With the pipe portal and the mag tag, I remember we were doing like demo projects, and sometimes the feeds that we were hitting was just like the classic photo of like a snake eating an elephant.
Right.
Or, yeah. Wow.
Yep.
Do it.
Yeah. So it does use allocations, but it's kind of doing it one value at a time. And it uses the built-in JSON library under the hood to like parse the strings and stuff. So you don't have, it's just like what you're talking about. It's like you don't have the big animal going through the Python. You get lots of little small things going through it instead.
This is handy. All right. When, where, what can people find out more about this?
I'm done for today pretty much after this, but tomorrow I'll post it and you can find it, just, Adafruit CircuitPython JSON stream. If you want to know kind of more, you can take a look at the JSON stream library that already exists, but it doesn't use the built-in JSON for parsing, so it's like a lot larger. But the one that I made here is like somewhere on the order of 200 lines.
Yeah, this is really great, especially you mentioned for the Pico W, because you're already losing so much memory to the SSL stack that you kind of need it. Like, we talked about like the S3, there's like ESP32 S3s that have like 4 megabytes of PS RAM, but
right.
On the Pico W, you're limited.
Yeah. Yeah, and I actually like experimented with trying to like change CircuitPython to give me more memory, and that still wasn't enough. So
yeah. All right, well, this is
like,
really useful, though. I mean, like, there's like JSONs that like I get that are like 500K. There is a limit. At some point you're like, uh-oh, I actually can't fit it.
Yeah, so hopefully, like, I think that the requests, the Adafruit request implementation, I think is actually good enough that like it will only load so much data before, like it should, I think, push back all the way to the TCP level of like ingesting the data as you need it. Instead of like, so you'll never get the whole response if you can't.
Okay. Well, this might be neat to combine this with some of the DVI, the screen stuff, because you could get some really interesting data sources and then display them on a TV.
Very cool.
Yeah.
Very handy for
when you're memory limited.
Yeah.
Yeah, we were doing the DVI. That this new product this week is the DVI cowbell, and I definitely like choked out. I was like, oh my god, I want to do some cool data stuff, and I was like, oh my god, I have 5K free.
Yeah.
Yep. Yeah. Yeah, so it does use memory. It will churn memory, but it won't do super big bulk stuff, hopefully.
Okay.
All right. Well, thank you so much, Scott.
People are in the chat, posting in the chat, cool things they want to get to now.
Yeah.
They're going to test us out for you.
All right.
Thank you,
Scott. We're going to go to Brent and then Jepler. Brent, what you got going on?
Hi. Also doing optimization related things. I'll share a video of like an issue I hit this past week, and I'll talk about how I got over it, and I'll share that. So I have the video. I don't know if you can add that to the show, Phil.
Yeah.
So this is LVGL, which is a lightweight graphics library running on a funhouse. And the funhouse is also running our wippersnapper application, which is our no-code way to do IoT projects. And this is where it's at. It's really nice. It has this little status bar on the top. It also has tips that rotate around, kind of like a video game loading screen. And it connects to Wi-Fi. It attempts to connect to I/O. This issue I'm currently working on. But and then there's like an error screen when it doesn't connect to I/O with like the wrong credentials. But once you connect to Wi-Fi, there's a really jarring issue where it sits at 100% CPU usage. And that was starting to hit me last month, and I worked around it with Phil B, who came up with we have this library called LVGL glue. So all of the Adafruit displays can use LVGL in a really easy to use way, and Phil B, Paint Your Dragon, developed it. And I was working with him on like getting around this issue, because it seems like every single time you do a project and you bring in the overhead of Wi-Fi or the overhead of display and Wi-Fi and NeoPixels, like you're really starting to constrict like what you can actually do. So this issue cropped up again and again and again, and it got past it, but it didn't get totally past it. So today I spent time working on, so like I realized that LVGL isn't thread safe. And what that means is like the ESP32 runs on a real-time operating system, and there could be like memory corruption between things trying to access when the Wi-Fi is connecting and also LVGL trying to render. So I currently have a board running nothing. Like this is just running LVGL. And hold on. Of course, I just bumped it. Great. So I got it. I don't know why it's resetting right now. I got it down to like 4 to 6% utilization when it's running LVGL now. So it puts it on another core, and it puts the Wi-Fi on a separate core. And every time it needs to call LVGL within like the wippersnapper application code, it like locks the resources as well. So like everything is now done really nicely. And then if people are looking to make their own projects that use this, I'm going to work on making it like a nice, easy to use API. So people who want to do IoT projects and display their data in a really nice way and send it to the internet, which is like what everybody wants to do, can actually do it.
Yeah, definitely. It's because you're chatting with me, and I'm like, it is kind of like, like system integration, and this is the hard part. It's like, okay, you've got the graphics, okay, you've got the Wi-Fi, okay, you've got the status messages, okay, you got MQTT, but then you actually try to put it together, and that's when things get complicated. You can't really get solutions. You're like, okay, I'm going to use mutexes, I'm going to use multiple cores. There's a lot of stuff out there for microcontrollers that's not thread safe. Wasn't designed to run on free RTOS. But sometimes it's still faster to figure out how to do your own memory management than rewrite the libraries that you're using. But it is definitely a thing that happens. Everyone's bumped into it. Or you will bump into it.
And I guess like our job here is to prevent people from bumping into these things as well.
Yeah, we make all the mistakes, spend all the time, so you don't have to.
Mm-hmm.
Yeah, there's actually a very early thing in CircuitPython. Scott was like really focused on like how can we lock resources, because we don't want to have two things trying to connect to the I2C interface. You can have an OLED on I2C and still connect to a sensor, and it does the right thing. It magically never corrupts the data. That's not true in Arduino all the time.
Yeah, especially like the ESP32 board support package. Like it's such a deeply integrated like package that it's like there are RTOS in there as well.
Coming back and showing the progress of this.
Yeah, so once like now that it's working faster, I want to actually show it working completely.
Okay, but it's good to show the struggle.
Yeah.
Yeah.
Sure, work here. It's not. It all just doesn't come out perfect the first try.
Nope.
All right.
Thanks so much, Brent. All right, Jeff, what you got going on this week?
Hello. We're in a little bit different perspective on me because I got a new to me computer.
Whoa.
I was at an estate sale a couple of weekends ago, and I saw this and the keyboard, and I'm like, well, that's interesting, but I mean, what would I do with it? And then I saw the two 8-inch floppies, and I'm like, that's cool, but it's not like it's going to work, right? And so I wired it all up in this guy's basement and booted it to CPM, and I'm like, I can't say no anymore to this.
Yay!
And I brought it home, and I was playing with it until suddenly the smoke started coming out of this capacitor. So that was no fun. And now I've recapped some power supplies, so superpower unlocked. Anyway, so I was going through my 4 boxes of floppies, and let's see if we can get this on the screen here. Not runt.
Runt.
For Pete's sake. Okay, how do you recover from this? Well, I was going to run a program, but I typed runt, and now we're just done.
Or does it take 2 months to reboot?
And that's it. Now you have to buy a new one.
And that's it.
Can you
come
reboot
back,
it, or is it
come back to me in like 2 minutes. I don't want to have the drive box on because it sounds like a washing machine.
It's just like.
But I'll reload everything, and then
We'll
we'll
come
play
back
the
to you.
game.
Yeah, we'll come back to you.
Okay.
Yeah. Did you
Oh,
try to
that's
unplug
interesting.
it and plug it back in?
Oh wait,
There we go.
that's running.
There you
Now
go.
Okay,
it's
wait.
running.
Okay. You recovered. Okay.
Oh, you got a little enterprise.
Yes. Yeah, so here we are. Your orders are as follows. Destroy the 18 Klingon warships which have invaded the galaxy.
Yeah.
This is like a classic game ported to a lot of systems of the
This
era.
is what Google showed off at Google I/O today. This is their AI.
And I have no idea how to play it, so we'll figure that out later. But yeah, I'm just really excited to have this system, and I'm also going to figure out how to not put CircuitPython on it, but connect
Yeah.
CircuitPython as a device to it to enable something. So
That's a good
I'll
idea.
come back when that's ready.
Ooh,
But that's
you
what
can
I've got, a
have it
1980s computer.
This is super cool. So what's the total age on this? Is what, probably 50 years?
So-
That's easily 50.
No, it's 1981 or 1982
Okay.
hardware. So
Okay,
it's
40.
comparatively new. It's younger than me.
Okay. All right. Still a spring chicken. Okay. Thanks so much.
Very cool. Yeah, you can have it output to DVI. You could have it connect to the internet using
Yeah.
CircuitPython as an intermediary. A lot of
Yeah,
options.
there's all sorts of possibilities. Just have to
Okay,
write some
cool.
CPM code to do it.
Nice, yeah.
Track.bas. Thank you, Jepler. And
Next,
good work.
Maker Melissa. What you got going on, Melissa?
Okay, if you want to show my screen here, I have been working on a little bit of code here for the platform detect for Blinka. So one of the issues we've been having is they add a lot of new rev codes, and we currently have just like this list that we're just kind of looking up on, so it doesn't really do much on it. So I've been writing some stuff to decode it all, and so this is just a little test script here, but it's using a class that I wrote. So if I do something like D03114, then it's going to go ahead and tell me all the information about that rev code. If I want to run it again and do one of the old style rev codes like that, it'll go ahead and decode all that stuff. And
Oh, nice.
if I go ahead and I run it and we give it like a invalid rev code, something like this, then it'll
Yeah, it's not valid.
yeah, I ran this earlier and it wasn't. I'm not sure what that is. What that
Put back on
that's a
again.
bug I need to fix, I guess. But let me try that again because it didn't do that earlier.
Maybe it started with a 0 and it parsed as a like octal or
Yeah,
something.
see that's what it's supposed to do. It did, I think, the exact same thing here, and it worked. Anyway, it's supposed to say this code is invalid. Blah blah blah. So.
Great.
All right. And then where, if folks want to find out more about this, where, when, what, how?
Well, I'm going to go ahead and submit a pull request soon. So I just want to go ahead and fix that bug first of all, and then I want to modify it so that it just goes and checks it on platform detect.
Yeah, check out
Uh-huh.
Blinka support and CircuitPython.org, all the different boards that we support through Blinka.
Yeah.
All right. Thanks so much, Melissa.
All right.
Thank you.
Thank you, Melissa. All right.
Next up, JP. What
JP.
you got going on?
So I was just typing over here because Scott is actually trying to push the JSON streamer thing, and he was asking me about the sports viewer that I had on MagTag. So he's serious about this. He's in real time putting this thing out during the show.
This happened.
So I decided to have as many scrolling things as possible because that's the theme today. The main thing I want to show, though, is this little guy here. I'll just hold it up. It's going to be blown out. Sorry, I can't control this camera for that. But this is what I was showing. I'll keep it up here. I was showing yesterday on my product pick of the week because I was using a matrix portal with one of our nice 64 by 64 LED displays, and I happened to figure out through just playing around with it that display is exactly 18 Lego studs wide. So it's very easy to make your own Lego case for the 64 by 64 2.5 millimeter pitch, which is what I did. This has an acrylic, some of our acrylic LED plastic to help with diffusion a little bit. But that's all I wanted to show, is that I had a fun Lego build, and I've got a little cool guy there who's very mysterious.
This is one of those cosmic coincidences, just like the moon is the same size in the sky as the sun. That's why we can do total eclipses. Super freaky.
Why would it be 18 exactly?
Why? I can't. Well,
answer.
It had to happen
Check
once.
out JP's conspiracy YouTube.
Listen, guys. It goes deep.
So tomorrow, what are you going to show on your show?
Tomorrow we'll be playing around with some synth IO stuff that Jeff has been developing and that I am building into the Computer Perfection 1980s toy ashtray sci-fi prop thing that Phil discovered.
And speaking of Robert Smith, not the Cure singer, but a well-known Robert Smith now, is doing some toy controller hacking and just posted up on Twitter. Lots of people are posting up their wish list things. We put some photos up on our Flickr of the USB-C version of the one that you made, and then Robert put up a guide. So if anyone wants to hack like toys that weren't meant to be game controllers, we have a new guide. Yeah, it's really neat.
Yes, that's great. In fact, I have something also from the Fisher Price line that is
we got one
block for something at some point. It includes a spring-loaded cartridge that I don't know. I just want to gnaw on all these now.
Yeah. All right. Well, thank you so much, JB. And see you
all right.
All right. Next up, we're going to go to deshipu, then Delchi, and then DJ Dev. And deshipu, I haven't seen you in a while.
Hello, what's up?
What you got going on? Oh, unmute your mic when you get a chance.
Now it's working.
Yeah.
Okay.
How you doing?
I'm great. So the show is a bit late for me because I'm in Europe.
Yeah.
So that's why I'm not coming here.
What you got? What you working on?
Yeah. Well, you probably saw. I posted photos of this. You saw this.
Yeah. It's cute.
We've built a couple dozen of those recently on the Hackaday Berlin, and it's basically 8 servo walking robot, was like this, and because this is an ESP32S2, it also exposes website. Oh, yeah. It's such a shame you can see it.
Yeah, it's all good.
We believe you.
Basically, with 4 buttons that you can use to control
You control it. So you have a remote control robotic crab spider.
Yeah, basically that. I also developed a number of because this is the S2 Mini development board. So you can use any of the shields that are for D1 Mini or S2 Mini. And I also developed a number of shields you can use as a face. For instance, this nice round display.
Oh, that's good. So you can put different faces on it. That's a friendly crab.
But you can also put a sensor, for instance, a distance sensor or a gesture sensor on it, so that you can train it to do tricks depending on what gestures you do in front of it or things like that. So with Jeff doing a lot of work some year ago with the camera, I also made a camera shield for it, so you can put a camera on it, and you can actually modify the HTTP server in CircuitPython to stream from that camera.
Ooh.
So then you can, on that website you have with those 4 buttons, you also have the stream from the camera.
Neat.
I don't have that working right now. As I said, you need to hack the HTTP server library a little bit to not close the socket, because I'm using async IO internally to do several things at once, stream from the camera and walk at the same time, for instance.
This is super neat. If folks want to build these, where can they find out more information?
Right. I put everything on hackaday.io. So all the documentation is in there. I will post a link in the Discord.
Oh, thanks.
I just wanted to quickly show one more.
Yeah, what else you got?
Guy. So I'm using those LiPo batteries that are quite convenient for me. Those are mostly used for vaping.
Yeah.
And I found there is a battery that is a little bit
Oh, that's
smaller
cute.
than that, but looks the same. And there are also those servos that are a little bit smaller but look the same.
Your cute batteries and servos.
So I decided to make a robot
Oh,
that
that's
looks
a cute
the same, but it's smaller.
Tiny.
It's the same kind of battery.
Yeah.
only the
Oh, it's a
smaller
cute
one.
little girl.
Okay, it's little friend.
And it uses the, I don't know if it's actually at the fruit or if is it Seed Studio. This one is Seed Studio Xiao board, but
Oh, that makes sense. You could use a little cutie. Oh, that's cute.
Cute.
That's cute. Are you gonna put that up on your Hackaday.io profile?
there is one problem. You can't buy those servos anymore.
Oh, you can't buy them anymore. Okay. Well.
Yeah. So I will put the design files up there because
Yeah.
it's possible they will come back at some point.
Oh, that's
But,
really nice.
Those are from Hobby King, and they discontinued them like
That's
5
so
years
cool.
ago.
I like
had
the
them
little one has
smaller.
the movement is really nice. It looks very organic.
Yeah, that's because of the async IO where I can have several like layers of animation at the same time, so I can move it forward at the same time as separate thread is moving the legs up and down.
Yeah.
So it's very organic because of that, because you don't really have steps.
Yeah.
It's all happening like.
All right. Very cool. We were just in a meeting not too long ago, and I had watched like a show about how everything eventually evolves to crabs in nature. Like everything eventually on a long enough timeline. So it's great. This is starting
Including
to
hardware.
This is starting to make me think it's true. All right. Well, thank you so much, deshipu. Great to see you.
Thank you.
Thank you.
Bye.
All right, we're gonna go to Delchi, and then DJ Devin's gonna play us out. Delchi, what you got going on?
Hello. Can you hear me?
Yeah.
The long-awaited, finally returned of Rolling Thunder.
Woo!
Yeah.
We have re-outfitted it with NeoPixels, and we've got a fresh Raspberry Pi 4 on the back. It does a Wi-Fi hotspot. It projects a Galaxy projector. That's a little spaceman in the upper corner there.
Oh, yeah.
It has a sound system, and it runs Kismet in the background.
Well, yeah.
Okay.
So I just today got this back going after a complete refit of the motor assembly and fresh batteries and rewiring. So the Pi goes back on next, and then all new code in time to roll this down the street to DEF CON.
Yay.
Outstanding.
That's
All right.
awesome.
And even more fun, over on the bench, this is a gift for a friend of mine. Back in the 1980s, Radio Shack made these little toy fireman's hats. And you can see it had a little battery and a rotating motor.
Yeah.
And it would just rotate around. And it was literally a physical motor and a piece of metal and an old light bulb. So I gutted it, and I put in a little Adafruit board, a little NeoPixel or two, and when you hit the switch,
Oh, cool.
I don't know if you can hear it.
Just a little bit, yeah.
It plays the Beto alarm from Minions.
Nice.
Yeah, hold it up to the.
Oh, yeah.
There you go.
Yeah.
So, and it's programmable through the USB cable, but
Yeah.
you can see
Tons
I've
of-
kept the original structure.
Yeah.
And just took out the original parts, and there was like battery acid everywhere, and it was just pure evil.
Yeah.
But I modded it up, and it's going to get cleaned up a little bit, a little coat of paint, and going back out to one of my friends.
Sweet.
All right. Excellent projects. And if
And-
you have any photos of either one of them, let us know. We'll post them out.
This is a piece of ancient technology called a craft access terminal.
Ooh.
It's very similar to what people call a lineman's handset, except it had a 300 baud modem in it, and you could use it to connect to the switch to turn a phone on or off if you were a lineman doing your job. What I've done is I have gutted most of it, because who needs a 300 baud modem anymore? I replaced the screen with a Pi portal, which fits perfectly right in that spot. I'm getting a GPIO expander board so I can use the original keypad to do touch tones, and it's going to become a portable lineman set using Pi portal.
Oh, that's
Nice.
cool.
So it'll be a dialer. It'll do your various boxes. I've already started on the code, but I'm missing a few parts, which are on their way to me, which I ordered 2 days ago. So I'm very, very excited about that.
All right.
And again, I hope to have that all good to go in time to show it off at DEF CON.
Outstanding.
Okay.
All right. Well, thank you so much. And send us any photos or put them in the chat so folks can find out more.
Yes, this I will do.
Okay.
All right.
All right, watch out driving down to DEF CON because people are going to think that you're part of like some, casino display. They're going to be like, they're going to try yanking things on you to see if coins come out.
All right. DJ Devin, play us out.
Oh, can you hear me?
Yeah.
Okay. There's been a lot of Feather DVI projects, so I did like a temperature thing. There's temperature up here, or pressure, and then humidity over there. And give me 1 second here.
What's the 1015.9? What's that?
That's the pressure.
All right, looks great.
And then I cheated because you can't put the airlift on there, right? Because it's just not enough RAM. And I tried GIF-IO2, and it just doesn't work like that. So I cheated, and these are 3 different browser windows open. And obviously, you guys and Brent will probably recognize Whippersnapper is running in the background.
That's a good idea.
So if you combine that with that, and I bought from Adafruit an HDMI capture, so I'm capturing this, overlaying that, and we get this.
Oh, that's a good idea.
Oh, check that out. That's
a good idea.
nice.
That's a good idea.
A pragmatic use of the Feather DVI.
Yeah. Yeah, this is neat. This is what we were hoping people would do with this, because you can kind of mix and match a bunch of different data sources, and then you could do some neat things with video overlays, and then you get your own like dashboard the way you want it.
Exactly. Yeah, it's pretty cool.
All right.
And as you can see, this will be on my GitHub under Feather DVI, because I have boards, Raspberry Pi, Feather DVI. I organize my boards just like you guys.
All right. This is a great project.
Nice work.
As you can see, it's getting pretty hot in Florida, and I'm pretty sure that I got a fever right now. There's only one prescription.
Yeah. More cowbell. Yay! All right.
It's a party at DJ Devin's house.
All right. That was an excellent way to play out show and tell.
Thank you, DJ Devin, also known as Dragon Jockey Devin.
All right. So that's our show and tell for the night.
I don't even know what I just saw.
We'll be back next week. Thank you so much, everybody. Amazing projects and more.
The creativity is amazing.
Yeah, thanks for making this the best half an hour of a week. Every single week. We love seeing the projects. We'll see everybody on Ask Engineer in just a couple minutes. Bye, everybody.
Bye, everybody.